Hi there, this is Prof. Johan from the Department of Chemical Engineering at the University of Pretoria. Welcome to my series on the Introduction to Chemical Engineering and Chemical Engineering Principles. Today's topic will be the difference between absolute and gauge pressure. So what is absolute pressure? As the name indicates, it is an absolute pressure that will go from 0 to some sort of positive value. So this implies that absolute pressure must always be bigger than 0. You are already familiar with absolute temperature. So let's have a look at this. PV equals to nRT. Now we know that in this equation the temperature is an absolute temperature, and we also know that absolute temperature can be 0, not less than 0. Now for this, if the absolute temperature is 0, then the right-hand side of the equation becomes 0, and then the left-hand side of the equation must also be 0. But we know that if we have a given volume, the volume cannot be 0. So the only thing that can then be 0 is the pressure, so that the left-hand side will also be 0, and the equation will hold true. Thus, absolute pressure must be bigger or equals to 0, and absolute pressure can never be smaller than 0. Gauge pressure, on the other hand, is a relative pressure. So this implies that gauge pressure can be bigger than 0, it can be equals to 0, but it can also be smaller than 0. So what is this thing that gauge pressure is relative to? So let's start with a pressure gauge. There's my value 0. Let's say it goes to 400 kPa. There's a 200 kPa. And I now have this gauge reading 0 kPa. When is it reading 0 kPa? I decide. And I decide that at a given atmospheric condition, this gauge will read 0. And what is this atmospheric condition? It is the atmospheric pressure. So I go and I say that I have an atmospheric pressure, which at that point my gauge will read 0. So at sea level, or at the coast, where I know that the absolute pressure is 100 kPa, I now set my value so that my gauge is 0. This means that for P gauge to be equals to 0, it must be that P absolute minus this atmospheric pressure must give me 0. Now at sea level, I said that the absolute pressure has 100 kPa. If I now make my atmospheric pressure 100 kPa, then my gauge pressure will be 0. Obviously, I could have changed this and say that at Pretoria, where the absolute pressure is approximately 87 kilopascals, I will still have, and I set my gauge now to be equal to 0, I will still have a gauge pressure of 0. So then, I now have my atmospheric pressure and my absolute pressure to be the same, so that my gauge pressure can still be equals to 0. So this is the definition of gauge pressure. Gauge pressure is a pressure on a gauge set to 0 at a given elevation where the atmospheric pressure is known for that elevation. As easy as that. Now let's discuss using absolute gauge and atmospheric pressure in calculations. So there I have a container. This container is filled with a gas that I have just put in the container at the same conditions as the atmosphere. So outside we have the atmospheric pressure. Inside I have the atmospheric pressure. If I now put a pressure gauge on this, it will read 0. I now go and I pump additional gas into this container. Suddenly the pressure will go up because I have more gas there. So P in my volume will be bigger than P atmospheric. Because I've put more gas in there, the pressure is now higher. We understand that. This implies that this P in the volume, if I express it as a gauge pressure, must be bigger than 0. I could also say that the absolute pressure in this container will now be bigger than the atmospheric pressure. Think about it. In the beginning, the absolute pressure in there was the atmospheric pressure. I've put more gas in. It's gone up with the gauge pressure. That means that this absolute pressure must be bigger than the atmospheric pressure. And the amount with which this absolute pressure in my container is bigger than the atmospheric pressure is with the gauge pressure. So, yet again, P gauge in my volume equals P absolute in my volume minus the atmospheric pressure. We could also take the exact same system and now take some gas out of it. Suddenly, the pressure in this volume will be less than the atmospheric pressure. So the gauge pressure in this volume must now be smaller than 0. Because we've taken some gas out. The gas initially was at the atmospheric pressure. We've taken it out, so the pressure must go down. And it is the absolute pressure in this tank must now also be smaller than the atmospheric pressure, but always bigger than 0. And it is smaller than the atmospheric pressure with the gauge pressure. So I hope this helps you understand the difference between absolute and the relative gauge pressure, where we go and we choose that the gauge pressure is 0 at a specific atmospheric pressure. Thank you for listening.